Hello, I'm Robert, also known as the Logic Geek. So today I want to talk to you about Linux versus Windows when it comes to .NET 5 deployments. So I'm a .NET developer, and recently in the company I work for, we switched our websites to .NET 5, which has been great. It's been a performance boost, and it's been just lovely to work with. We get those new C# 9 features we can use, and it's been awesome all the way. But there's one question in my mind remaining, and that is, should we deploy our applications on Windows or should we deploy our applications on Linux? And in this video, we're going to try to find that out. So what we're going to do is we're going to create two VMs. We're going to create a Windows VM and a Linux VM, both with the same specs. We're going to use Windows 2019 for the Windows variant, and we're going to use Ubuntu for the Linux variant. And then we're going to deploy on both servers the exact same application to see which one is faster. Because Linux VMs are quite a lot cheaper than Windows VMs. But it stands to reason that if you run a Microsoft-based, development stack-based application on the Windows server, it will be more performant than when it runs under another platform like Linux. So let's go to my desktop and see which one is better. So let's open up Visual Studio and get started by creating a small demo application. So we're going to create a new project. We're going to go for an ASP.NET Core web app model view controller. I always like my MVC applications. Next, we're going to call this performance test. And we're going to save it at C Logic Geek performance test. Next, I'm going to choose for .NET 5. We're not going to configure HTTPS here. We're just going to send requests straight to the application without any middleware. So no nginx on Linux and no IIS under Windows. So create. Choose .NET 5 here. There's our files. So this is our home controller. We're just going to leave it as it is. Nothing to do and nothing to change there. So it comes with a standard view, the index.html. Let's change this to welcome to our performance test, where we find out which is faster, .NET on Windows or Linux. Now we're going to create a small API controller. Just going to start from class. So this is going to call it API controller. Since this is an API controller, we're going to give it the API controller attribute. And we're going to have it inherit from controller. Then we're going to go and create a public iAction result. Say hello, which is just going to return an OK with hello world. And we're going to have a more complicated one. Say my name. It's going to receive a name input, so name. This is going to have a get on /API /say my name. And this is going to have a route on API /hello. And this is going to use a class, so we're going to create a model for that. And they always do this. I still don't understand. First thing I always do in a .NET application is create a new folder called view models. And we're always going to move the error view model over there because I like to keep my models and my view models separate. So we're going to create a new class here. We're going to call it person. And person has a name. And person has an age. Int age. They're both going to be parameters for this method. Now we're going to create a person object. Could actually do this, right? It's the new C#9 feature where you don't have to do person p is new person or var p is new person. Not sure which is better to use, either this format or this format, but let's try the other one. We're going to initialize it with property states straight away. So name is going to be name and age is going to be age. And then we're going to return JSON type P. So now we can see JSON serialization in action as well. So let's keep it at this. I don't want it to be too complicated. So we're going to run 3 tests. So one for hello world, just a 200 response, and one where you send 2 query parameters, and that it returns a JSON object. So it's going to construct an object in memory and then return that as a JSON value. And we've got on our home controller, we've got our basic HTTP get on the view. So that's it. Let's clean this up. Always like it if we don't see unused usings. This is really a magic button on the bottom here, by the way. Run code cleanup. I always use that several times a day on each file I'm working on. Always use it before I commit. So let's test this application real quick, see if it works. That looks okay. API.hello world. Oh, no, I will call it hello. There we go. And say my name. Name is Robert and age is 34. Doesn't need to be capital. And we get a JSON object back. So that works as expected. Great. So now let's publish this to be a Windows application. Let's do a folder. Yeah, that's fine. So I want to have this as a 64-bit Windows application. And I want to have it self-contained. Produce a single file used ready to run as complication and trim unused assemblies. Save. Publish. Okay, there we go. You can run this. We have an application and that works. Great. So no single file. Apparently there's still a lot of files here. That's fine. Now we're going to create another profile. And this time we're going to create a Linux profile. So I'm going to call this a Linux. Finish. And this is going to be, target runtime is going to be Linux x64. Produce single file. Publish. So we're going to create a new virtual machine. So this is on my Visual Studio Enterprise subscription. We're going to create a machine called WinTest in the WinTest group. We're going to create it in West Europe. No redundancy required. We're going to use the 2009 data center. We're going to run it on an F1 instance. We're going to give a username. We're going to give a username called WinTest. We're going to give it a password. And I'm not going to tell you what the password is. Otherwise, you are all going to hack this. I'm sure of it. So let's just review and create. Yeah, fine. Create. So now we're going to create another VM. So while these are these are in progress, in the progress of being created, let's first, next up, create our load test. For this, I'm going to use a program made in Python. So let's open up Anaconda. So you can run a local Python environment. And I've already created a Locust environment. So for people who don't know what Locust is an open source load testing tool which we're going to use to test our endpoints. So let's open this in terminal. We're going to go to Logic Geek. Make their load test. And then code. We're in load test now. We're going to create a new file. It's going to call locust file.py. I've got some boilerplate code here. So we're going to call hello. We're going to do a task root for the home page. And so we're going to call this home page. And then we're going to create a task. Say my name. API, say my name. Name is Robert and age is 34. That's it. So in this load test, we're going to access all those 3 endpoints. And we're going to run this for as well as the Windows server as the Linux server to see what will perform better. So let's run Locust. It opens a web interface. We're going to go to localhost. There we go. It asks me the total numbers of users to simulate, the spawn rate, and the base URL. So the base URL without the slash, because that's already in our test file. So both VMs are created now. So let's connect with the Windows version first. So let's copy that. Username was WinTest. And then local resources. More. Drives. I'm just going to link up the C drive so we can find our files. So we're connected to our Windows VM now. I'm going to create a folder here. Performance test. We're going to copy over those files. And while we're busy, we're going to open the firewall. So I'm not suggesting you do this ever, by the way, but I'm just going to turn off the firewall to make sure that all incoming ports just work. Because this VM is going to be deleted as soon as we're finished, so I don't think we're really going to be hacked in that meantime. And we also have the outer firewall sort of thingy from Microsoft Azure. So let's run the application, see if it works. So now let's go to networking and add an inbound port 5000. Port 5000. Add. And now this should work. And there we go. So now we can run a performance test. So we're going to use 1000 users, spawn rate like that. And we're going to not show the last slash because that's already in our locust file. So we press start swarming. And now we wait. So we're already at 260 requests per second, 270, 285. 294, this is quite low, 305. Really waiting for the moment for this to fill because, yeah. So, imagine 350 requests per second. Times, and if you look at the response times, it's just 110 milliseconds, average 35, 9, 17 total. So, you're going to increase this. 450 times 60. So that's 27,000 requests per minute times 60. That's over 1 million requests per hour on a 1V CPU, 2 gig RAM virtual machine. So this is really impressive. So 500. And our response time is still really acceptable. Really acceptable. Still at 0% failures. We're running with 1,000 users now. And now you can see our response times are creeping up. They're going up. They're still well below 1 second. You know, this is still 1/5 of a second. So 1/4, to be honest, my bad. But it's blazing fast. We're still slowly increasing in requests per second. We're going down a little bit. I think we're about there. So yeah, let's stop this. So 566.9. So let's just round it at 560 requests per second with perfect performance. And that for a single CPU and 2 gigs of RAM. This is, I know it's just a simple application, but this is really impressive. It means you don't need a big server. Because, you know, this virtual machine is running Windows as well. So either Windows is really optimized for running .NET Core applications or .NET 5 applications, or we're going to have even better results under Linux. So let's log into our Linux VM and find out. So now we've got our Windows VM tested and we had an amazing result. So next up is going for our Linux VM and installing the software. So we're going to copy the public IP address. We're going to open Windows Terminal, SSH into this machine. Yes. Enter my very secret password. And there we go. So machine is running. So now we're going to copy over our files. Let's open FileZilla. Enter the IP address. Linux test port 22. Now let's find our folder where our application is. Copy over our files. And then here we should have the directory. Yeah, we do. We're gonna make the performance test executable. So let's run it. Yeah, it's running. Yeah, of course that isn't working. So now we need to forward port 5000, just like we did with the Windows VM. So we go to networking, then inbound role, port 5000, port 5000, add. So when we visit this IP on port 5000, so we do API/hello, and there we've got our hello world. Perfect. So now we're going to copy paste this to Locust. We're going to restart Locust. Remember this number 566.9, because that's the number we want to beat, or well, we're going to see if we can beat it. So we're going to run Locust again, just to make sure we start with a clean slate. Refresh the view. There we go. I'm going to simulate 1,000 users with a spawn rate of 10, and copy this to Locust. Remove the last slash, otherwise everything's going to be horrible. And we're going to start it. Oh, this is exciting. So we just passed the 500. This feels faster than we had with the Windows version. Our average response time is still really low. 7 milliseconds only. It's nothing. 571, 572, 568, 9, just past 570, and our response time is still really low. So I think we've actually hit our limit. We're at 568 now. Yeah, I'm just going to stop the test here. and see this average response time 7 milliseconds, a max of 78. It's just phenomenal. So let's download this as a report, and let's save this as a PDF file. Linux test report. So let's put those two next to each other and see what the actual difference is between those. Under Windows, we hit an average of 420 requests per second. And under Linux, 423. I must admit, that's a really small difference. But if you look at the response times, the max response time under Linux was 78 milliseconds compared to 282 under Windows. And the average here was 6 milliseconds, and here 17 milliseconds. So, based on these statistics and the fact that Linux is cheaper, I would choose Linux anytime over Windows here. So that's our conclusion. Linux is faster than Windows. You could very clearly see that the average response time was so much lower, and that it's just a lot better performing. And if you take into account that Windows is a lot more expensive to host than Linux, then it's just a really good deal, because you can go to Linode and get a similar VM, or to DigitalOcean for about $5, Amazon Light Sale, things like that. And you can run really big websites of those. So if you want to have the best bang for your buck, go Linux. That's basically my conclusion. I want to thank you for watching. If you like this video, if you want to see more of these kind of videos, let me know. Please subscribe, and see you next time.